business is keeping DC buses of frequency inverters and servo inverters at a stable position. Since 15 years we are supplying safe brake resistors that are specially made for the application together with frequency inverters and servo drives. Now, about a year ago, we started to offer an active brake resistor, the so-called dynamic energy supply, DEV, which is able to take out energy of the DC bus of a frequency inverter whenever the voltage of the DC bus reaches a certain level. And this energy will be given back to the frequency inverter whenever the voltage wants to go below this level. So it's a give and take, and it's an energy saving device which we have in some applications saving up to more than 20% of the electrical energy. At Hannover now we present our dynamic energy supply in another version, which is a UPS. It's a power supply for frequency inverter, a real international specialty, an invention, the first time ever that is shown to the public. It's working like a power supply for any other device, but we are at a high voltage, at the DC bus voltage, and I show you how it works. Here we have a working cycle with accelerating, keeping at a speed, and decelerating to a lower speed. What you see at the lower chart, you see the voltage of the grid and the voltage in the DC bus. So when we take off the grid, we have a power failure, so to speak. What we are doing now, you see that the power of the grid goes down to 0 volt. We keep the DC bus voltage at 470 volts. That's the DC bus level every frequency inverter can work with. And here you see that our dynamic energy supply is still having some energy. Whenever the grid is coming back, when the power failure is over, we are loading again our dynamic energy supply storage, and the cycle goes on forever. So it's a UPS for inverters or for servo drives, and not only the control has a UPS with 24 volt, but here we present a UPS for the DC bus frequency inverters. So not only the brain still has power, but also the muscle.